Testing. Let me see. I'm trying to get my volume set up today. I'm going to do it so that it's sorry, what is this? This work? Hello, Yugami. Oh, I have two. Anyways, forget about what I'm saying right now. Um, yeah, I'm very close to my limits here. I pretty much am very burnt out, primarily from work. Dealing the refactor is very insane, so I'm very at my limits. And because there's still a lot of stuff stuck over here, I cannot realistically draw anything. I don't think. No, as a person that works, I think as an individual, I'm very tired, very mentally fatigued. I think today is one of the days where I probably should just not do anything. Uh, but we do what we can, and then I might have to stop early. That's not good. But at least websites. No, we're not gaming today. Today we're doing something pretty difficult as well. Sorry. You see what I mean in a bit. It is pretty complicated. But I'll get to that in a bit. I think just to wrap up, like website's pretty good. Website's actually pretty good because website we have all of the stuff, but all the very core stuff, which is all we need, really, all we need, all we can manage, and I can manage at this point in time. The core stuff is ready. It is live. If you go to the previous link, or you just go to mimi-me. Wait, I'll just type it in the chat. If you go to this link, you can see it. It's up, it's live, it's working. The first time you go is a little bit slow because the images take a while to load, especially on the portfolio page. Even though, so here's the thing: on the main page, you're pulling 5 basically 1080p images, and that takes a while. On the portfolio page, you're pulling multiple 4K images at about half resolution, so that also takes a while. So despite my best efforts at making the animation smooth, it doesn't really run that way. And this is definitely part of optimization. And there are a lot of things that we can do, like, for example, not letting the user see anything until the images are downloaded, decreasing the download resolution, all these kind of good things. And then you can go one step further, right? You only gate the viewer for like a split second so that the first image is loaded, and then when the viewer is on the first page, you then subsequently load the other images in the back. So there's a lot of fun ways, good ways to do it. It just takes more effort and more coding. So that's the website. It's fine. We just need to get the blog in. Thank you, Igami. The blog just requires a lot of writing. Honestly, writing is pretty much the thing that I can do today, I think. But I'm gonna try and do something. So today we have the other side of the equation. We have two things that we are working in terms of coding. Number one, our website, which I already just talked about. Number two, we have the analysis engine. And the analysis engine is a project meant to sort of essentially target specifically that one. Like, I remember a while back, we were doing stuff like collecting different hair references, right? We have hair references, and then we put them on a grid. We put them on the grid and be like, oh, sorry, I'm tired, so I like my brain just kind of stops once in a while. Let me just find it real quick, right? So we have the hair board that I shared a long time ago. This is like double-digit streams, right? So we have this board where we have essentially trying to sort of organize people's styles, people's way of drawing hair in based on style, right? Based on quote unquote what style is. But at that point in time, we haven't really got a very clear idea of what style really means. And in this case here, I think let me not talk too much tangent because I don't have the capacity. But essentially, we split it based on whether if there's a lot of lines being used or a lot of lines being used or less lines being used. By lines, I will mean like basically, do the shapes look long and elongated, right? So if the shapes are really long and elongated with a lot of lines, then they're at the bottom. But if they're bigger and more consolidated, bigger shapes like this, they're at the top. And then on the left and right, we have we have bigger shapes. Okay, you get the point, right? We're trying to put it on these axes. I'm not gonna. Hopefully I'm a little bit more coherent than what just happened here. But it is pretty bad. But so the idea is this is the very early version of this idea, and at that point in time it was pretty cool. You know, we were only able to do 2 dimensions because 3 dimensions is kind of hard to show, and anything higher is impossible inherently. But what we have then is the creation of the analysis engine, and the analysis engine is essentially the same thing, but across a whole lot of other dimensions. And the idea is that we don't just look at one part of the image, we look at the image overall. We can choose, in this case, just a number of pixels that are considered blue, red, and green. And of course, what is considered blue, red, and green, we define by ourselves mathematically. But once those math is done, are done, all you have to do is apply axes, and then now you have your distribution. You can clearly see that there's a bit more red here and a bit more blue here. And using this, so this system is set up so that you can use any number of compute any number of different features into numbers and then display them on a grid. And the whole point is that you're able to find artists that are similar and artists that are different depending on the selected sort of axes that you want. In this case, it's red and blue, right? You can go in. I'm not going to zoom in too much. Again, we have a bit of a problem with explicit images here. There's a good chance that something here on screen is explicit, if I'm being honest. So I'm not going to go in any deeper than this. But you get the point, right? That's the whole point of this engine. However, this engine is not color boundary shape. Yes. So here's the thing. The way that this whole thing works is that this website is a shell. This what we call analysis engine. Well, what the AI decided to name it as ArtMap, but I'm gonna change the naming down the line. But the way that this thing is just a structure. It's just a shell for displaying data. That's all we have. The thing that truly generates this relationship are scripts behind the back going in and mathematically taking the pixels of all these images and then computing a specific number. This number, which if I can just choose one that is safe here, for example, this piece here, these numbers are computed over here. And for example, pixel color set, you can see like the number of blue light pixel count. That's like 2.29 million-ish, I think. From these numbers here, they are, I forgot if they're normalized or not, but essentially they're converted to a coordinate axis, right? This is X and Y axis. This is just your typical math X and Y axis. You can see it here. And based on that number, it is placed in a position on this grid. So we need this number. And in the case of blue and red and green pixels, it's very easy to understand. You go through the entire image, pixel by pixel. If the pixel meets a criteria, which we in this case consider as blue, we're going to increment by 1. And that's how we get this number here. But if you notice here, if you just zoom in here, right, the scripts are not very powerful at this point in time. You can see that the thing that is considered the most blue actually doesn't really have a lot of saturated blue. It is just a more general sort of desaturated blue, but it's everywhere. As compared to something that is this, which I would personally consider as more blue than this. So here's the disconnect. Here's the biggest challenge of this entire project is that when you're perceiving art and perceiving styles, you're perceiving them more as a whole and more in a slightly different way than what a program might consider a blue. And of course, it's up to us to decide. But if you think about it in a programmatic way, if all we're doing is going in and counting pixels and being like, hey, this pixel, is it blue or not? Is it blue or not? Is it blue or not? Then you kind of have to, you will end up with this distribution that we have, right? Because I can consider, for example, I can change the code to say that only pure blue like this is considered blue. But then all of a sudden, what happens if you have a red image that happens to have quite a lot of blue pixels in there as well? Then you will end up having some red images here now. So does that make sense? It doesn't make sense either. So how are you supposed to then create the scripts and compute the numbers in a way that is not just like mathematically makes sense, but also it like intuitively makes sense? So that is the biggest challenge. And of course, this is just very simple math in terms of computing colors. If you're talking about artistic style, you're not just talking about the colors, but you're talking about where the colors are, right? Think about it. There's a difference between using a lot of saturated blues in the highlights versus using a lot of saturated blues in the shadows. That is a very distinct difference in color choice. And it partly relates to the lighting, but it also partly relates to the artists themselves. So there are some things that can be captured, some things that cannot be captured. Currently, the biggest problem is that we don't have these scripts. And these scripts here are very math heavy, and they're very, very hard to fine tune. We're not going to do any of these sort of difficult mathematics today. If it helps, I have a really big report here. I'm just going to download it real quick. Let me just export the PDF here. Let's see how long it takes. Oh, it didn't take too long. Let me open it up with, let's see if Firefox opens up this. Okay, so I got ChatGPT to compile about 700 different searches online with about 48 different math papers. So these are proper papers. And this document is so information dense that it's really hard to read, because you get to the point where every other word is like some kind of a weird keyword, and you just have no idea what it's talking about. So you have, like, for example, talking about rendering quality, you're talking about the style in terms of how line dominant versus color dominant it is. And then you have different things like line extraction, canonical edge detection, edge map, gradient magnitude distribution, widely used, well specified, implemented in main CV library, CV being computer vision. And then you have all these coherent line drawing, DOG, X, DOG variants. What do they mean? I have no idea. So in order to implement the stuff that we talked about, we're basically going through multiple people's life works, is how I'm interpreting this. So that's going to take a while. However, there is something that we still have to work on, is that I mentioned that the website itself is a shell, right? This website is a shell that facilitates the computation and display of the data. The problem here is that the website itself right now is in a decent spot, I would say. There's a lot of features that are in there. There's a lot of quality of life stuff. There's a lot of stuff that makes the tool intuitive to use. However, the very important thing is actually the way it computes data. Because once we start churning data, it's going to get really, really big. And there's a huge amount of data sets. Currently, we have 5,000 images that we want to plot and group them together. Also, I figured I should probably mention now, it's very sort of, I think to a layman, it's very similar to what an AI model might appear to be doing. We're not doing any sort of AI training. That's not what we're doing. We're just trying to extract features to group them so we can, as artists, view them from a specific point of view in a more objective way. So that when we compare styles, when we study from different artists, it's a lot easier to understand what the similarities are and the differences are, essentially, is what it is. It also doubles as sort of like a find similar artist engine eventually down the line, if things do work, by the way. This is assuming that if things work. If this is very much a research project. This is very much, by the way, if you're doing stuff like PhDs and stuff, a research project, this is kind of what it looks like. You have an idea, you try to execute on it. You have a supervisor that you can ask, which is your professor. Half the time he tells you something that's probably not very useful. And then you're on your way, right? Whether if you make it or break it, it's up to you to collect data, to do things, and present a report to convince people that you're smart enough to be a PhD or a master. But anyways, I digress. Just to put it out there, right? I know like now it's probably just you, Igami, or even if there's no one here, I just want to make sure that the things I'm presenting is all consolidated and cohesive as much as possible. I understand how this can look, but it is different at its core, as much as, you know, people might not necessarily want to believe it. But anyways, that's for that. So I'm going to describe the background process of this analysis engine. So the analysis engine has multiple parts at this stage in time. We have the user front end, which is what we're seeing here. So we have the front end. And the front end's responsibility basically is for people to see this relationship and provide tools to make it easier to find works by the same artist, and in fact different artists as well, right? And then we have the backend. The backend serves as a data sort of provider. So this is your typical HTTP stack. So over here, typical HTTP, typical web stack. Let's just call it web stack. And that's exactly what it is. There's nothing more to this. However, what drives behind this is the very sort of convoluted data collection and sort of processing process. So I need more space here. There's actually a lot more things behind the scenes here. So first of all, we have a set of ready-to-go data here. This is the package, the data. And in here, let me just make this smaller. And in here, there are multiple things. Number one, there are the computer features, but organized in a way that is useful. Useful to the code, I mean. Like, because when it's ingested by the backend, it needs to be in a way that's easy to process, right? Because human reading stuff versus computer reading stuff is very different. There's also a bunch of thumbnails that's generated. As you can tell, the front end itself does have a lot of images. If each one of these is a full resolution, my computer would have crashed long by now. Never mind being able to scroll around this smoothly. Look at how smooth this is. This is actually kind of insane. I want to show off like there's a lot of optimization in here, but we do have to zoom in, and I don't know what is risky and what isn't. There was a period of time where doing this is impossible because every time I scroll, my computer tries to crash. But right now, this is insane. There's a lot of optimization already done here. So that's the package data that is used to feed the backend, that is then used to that is pulled by the front end user. Should it not be this smooth? Should is an interesting word here because you should be able to make it smooth. There are always optimization ways to make it smooth, but in terms of how easy it is or like what is being expected here, when you have 6,000 elements on screen, by the way, there's like maybe 5,000 elements on screen, like about 4,800. So about 4,800 elements on screen. You can reasonably expect some lag, but you do not perceive any lag at this point. There's zero lag. You can kind of zoom in and out with zero. I'm zooming in here because I'm worried about explicit stuff, but you can see that it's not lagging at all here either. Everything is done so that the user experience is smooth here. But anyways, I digress. That's a lot of optimization that is not that important to this data pipeline here. Over here, we have the feature extraction. So feature extraction here is just a fancy computer science language for saying computing all the numbers that we are talking about. So a feature is think of a feature as like, let's say you have a feature of the landscape. A feature is like a mountain, perhaps, or it's like a building or something. Basically, things that stand out that you can identify an area by. In the case of images, it basically means something that is unique to the image. But colloquially, is like the word unique kind of implies something different. But essentially, just think of it as the values that we're computing. So feature extraction is just a pre-processing layer where we're computing these data points, such as the number of blue pixels, number of red pixels. And these involve feature extraction scripts. The orchestrator, and this is the pain in the ass guy. And then as long as the sub features here, so we have the feature extraction scripts, and then we have the thing, and then these guys in turn requires a data set, right? They need a data set. So there's data set. Data set. What do you call it? Data set. Preparation maybe. Sorry, I might have to go to the washroom real quick. I'm just gonna save this because I do need to keep track of this a little bit better now. Going forwards, this piece will serve as the center. centerpiece of document here. Anyways, I'll be right back here. Okay. Okay, that's a very unexpected story. I'm glad that they're fine. I'm assuming they're fine. But yeah, coming back to this, we have the dataset preparation, and in our case, it's primarily Twitter data. Right, Twitter says tweets, and we have our let's just call it the extraction. Let's not confuse the words here, so I'm just going to call it download scripts. And these are the ones that I released to the server about like 3 months ago. Last year, December, when we were talking about how Twitter is releasing Grok and making it easy for AI to edit images and stuff like that. We were wondering if artists will leave Twitter, and as a result, we wanted to sort of back up all the images. That was what we were doing. So if you look into the chat, there is a dedicated chat with a dedicated set of scripts and instructions on how to use it. That's essentially what this is, right? So this creates the data set that then feeds into feature extraction, which then feeds into the packaging of the data, which then ensures that the backend is ready and has data when user is in the front end and they're pooling for data, and then they can do it. So that's the entire pipeline for data. So there are some other interesting things here. For example, there's a resume logic. So for example, if you want to download just the latest pieces of bookmarks that you have, by the way, this is pulling from my bookmarks, right? So the resume logic is there so that you don't double download the same file twice, and so on and so forth. There's a lot of smart stuff in here. Same thing for the orchestrator, which we'll get to. This is the main problem that I have to sort out today, because the logic here is getting way too convoluted, and you will see why it's very complicated. But this is essentially what the whole analysis engine is, right? And computer science at its base is pretty much just information transfer. You're always talking about how information is transferring from one part to another part of the process of the program here. And this is essentially what it is, right? At a very big high level. And the issue that we currently have, right? So I've shown out the front end, and we have I have sent this part to the server before. And these things in the middle doesn't really matter too much for most people anyways. So the important gist of it, the money is at here. If we have good scripts over here, everything works. If we do not, nothing works and nothing makes sense. So the problem is this part. And this part requires math. And that math was the math that I was showcasing over here. Absolutely insane. I have no idea what they're talking about, levels of math. And today we're not worrying about this part yet. I'm not sure if we do that tomorrow or some other time. But the important thing today is what I'm calling the orchestrator. The orchestrator is a very important component of this. And the reason why is that when you're processing about 6,000 images, so we have about 6,000 somewhat files in the dataset. A good portion of them, about 1,000 plus, are either GIFs or video files, which don't matter. Like, they cannot really be processed that well, and also not that relevant just yet. We can extract a frame or two and then do a computation on that and then put the video in the place. But there's not much point, because the whole point of a video and GIF is that images are changing. So you'll most certainly be placing them in the wrong spot. Anyways, this is number one. Number two, we already have 4,000 other files, so we don't really care. So the bigger problem now is this part. I am going to talk about this part now. And this part here is not as bad as my refactor, but nearly as bad, I would say. So what is an orchestrator? Orchestrator is not like it's like a technical term, by the way, just to be clear. This is just what I'm calling it. But orchestrator is just something that orchestrates an entire process. And the process in this case is just feeding image files into multiple different scripts, ensuring that things are running smoothly, running in the correct order, and also doing checkpointing so that things are not a loss if your script or computer crashes in the middle, which is pretty likely at some point in the process. But let me see how I should present this, right? At its core, orchestrator is meant to just get the data done. So this part of the drawing here is going to be a mess because I'm also not 100% sure about this. This got really complicated really quick. So I'm just going to quickly write down a bunch of different things that it does. So number one, feeds... so number one, verifies dependency chains. So the idea of a dependency chain is that you have one thing that depends on one thing that depends on another thing that depends on another thing, right? So suppose you have A, B, C components and D components, for example. A might depend on B. Actually, I don't know what's a good way to draw the arrows. Let's draw the arrows in terms of what needs to come first, right? So let's say B depends on A. So A needs to be executed first. So this is first, right? And then B can execute number second. And then let's say C depends on both A and B. So this needs to run third, right? But then maybe D only depends on B here. So it can also run third. So you now have a situation where you have to run this first, then this, before you can run this and this in parallel, right? If you're following me, you're noticing that we're actually not always running in sequence because you have 4,000, 5,000 files. You don't want to be running things in sequence. It's going to take forever. You want to run things in parallel as much as possible. But there's multiple levels of concurrency here. There's one level where the scripts themselves are running in parallel, different scripts. But there's also the fact that you have 4,000 to 5,000 files each script. And those can be broken up and run in parallel. So you can run 50 images at C at one point in time. So there's a lot of different levels of concurrency. And as base, the core usage for the core role, the orchestrator, is to organize this process. So number one, we have to verify dependency chain because this is a OK chain, whereas A depends on B and B depends on A. This is a dependency cycle here. This is like, I forgot what's it called. But this is not valid because who are you supposed to run first? You can't run first. So this is not valid. So the first thing it does is to verify this dependency chain. Actually, let me move up. I'm gonna run out of space very quickly here. This is actually very easy to do. Mathematically, algorithmically, is not difficult to do. But yes, you do have to do it, and it does sound complicated, but this is not the complicated part. So the way that this is done here right now in the code is that we have a file, and I'll show you the file briefly here. It's a feature manifest. So this is the... So another thing that you might think about, like maybe or not, is that how does the script, the orchestrator script, know where to find the scripts in the first place? How does it know where to find ABCD in the first place, as well as the images? You have to register the ABCD to the script. So when the script runs, it looks at a list of stuff to do. So in this case here, it's running all these pixel computations and stuff like that. And you will notice that it depends on something. So this is our B and this is our A. It depends on this. So what happens is that the script will go through this dependency list and basically just looks at, hey, do you depend on anything? If you don't depend on anything, I add you to a list. If you depend on something, is there something in the list? Oh, it is? Okay, that means you can run. That's fine. And then you will just keep going. It will get to a point where maybe there are some features left over and be like, hey, they depend on something that is not on the list, but also nothing else is getting added to the list, and therefore there's a problem here. Let's just throw, right? The exact logic, I'm not 100% sure. There's multiple ways to do this logic. You can also take one thing and trace all the way. Like, for example, I can take B and keep tracing, right? I can take B here and just keep tracing and see, hey, does A depend on anything? If A depends on something else, does that thing depend on something else? And so on and so forth. So you can keep tracing that way, or you can just go through the list and be like, hey, A doesn't need anything, okay, add it. B needs A, but A is added, okay, let's go on. So it's not that hard. It's not that hard. So this is the core thing. The next core thing is to actually execute the chain. So the execution of this chain is also challenging in and of itself, because we have a couple of things that we need to contend with. So execution. Execution, the first thing that we need to contend with is the passing of data. So remember this, right? From the point of view of A, from the point of view of B and C and D, each one of them do not really know that the other things exist. All they know is that they need image file, they need data in order to output some kind of data themselves. That's all they know. So this script here doesn't really know if this thing exists or not, right? It only knows that it needs certain data to go in, which actually I'm looking at this is not it's not very clear what the data is. But regardless, it just knows that it needs something. So data needs to be passed around, and that's the job of the orchestrator. Essentially, the orchestrator ensures that these earlier stuff always runs first. The data is created and available. So for example, A into B. This needs to finish first. So like A's data. So finish first, and then pass it along to B so it can finish second. So uses A data. So this is the second job of the orchestrator, to ensure that this handoff of data is done at all, right? It's not just done well or done correctly, but done at all, because no one else is doing this. These scripts are not going to go call this. It's going to be a huge mess, because you will end up having multiple people calling the same thing, and then this will rerun multiple times, and it'll be very inefficient, right? So we only want to run A once, even though it's dependent on by two separate other things. So, and also you can imagine, like, if let's say for example down the line, let's say you have a situation where Z depends on every other alphabet in front that came before it. Those pieces of data needs to be held in memory until Z is ready before we put it into Z to compute some final outcome that we want. And if though the data is too much, you will have to offload that data onto a file. But then now, once it's on the file system, how would you know if someone else changed that file, corrupted the file? Then it becomes a huge mess. Of course, certain assumptions should be made that it shouldn't be corrupted. And if it's corrupted, just let it crash, because there's way too much work. But I digress. This can get pretty complicated as well. But for the most part, people just assume that things will work fine, which is what I'm going to do as well, because we don't really have time for this. So, oh yeah, let me just add some subpoints here, right? So A only run once, and data is passed along to everybody that needs it before being unloaded. Passes only what is needed. So that's the second one. So that's the 2A. So 2B here, what else does it need to do? It needs to do something called checkpointing. Now this is not absolutely required. Let me think first. Actually, is this part of the execution here? Execution, sorry. Let's not talk about that first. Let's talk about concurrency first. So we always talk about the computer having 8 cores, 16 cores, 34 cores, 32 cores, 64 cores. The whole point is that every core can run something separately. And concurrency has two concepts. I'm not going to go too deep into all the differences between threads and processes. Nobody cares, right? The point is that we want to run multiple instances of the script at the same time. Every script takes in one piece of data and outputs one piece of data, right? But we want to run multiple A's here. So we want to run them at the same time. So this is file 1, file 2, file 3, Actually, let's just call it input 1. I1, I2, and I3. So on and so forth into out1, out2, and out3. And these are run on different cores. So this would be core 1, core 2, and core 3. For example, right? This is concurrency. And concurrency is managed in two separate ways here. This part is the really complicated, the slightly more complicated ones, because it's a little bit hard to sort of wrap around all the different cases here. So, let me see. How should I present this idea, right? Because, right. So the whole point of concurrency is to run multiple things at once, but then you have limited resources, right? First of all, you're limited by the number of CPU cores. If you're running on CPU jobs, you can spawn like a billion different processes, but if you only have 8 cores, then there's only ever going to be 8 separate sort of sequences, series of execution. So on those cores, and this is, we're just gonna ignore virtual cores by now, for now, right? It gets very complicated. You have physical CPU cores, then you have virtual CPU cores. So every physical core might have 2 virtual cores, and therefore you might have 2 separate threads of execution. But it gets very complicated. We just ignore that. So we're just gonna talk about physical cores. So you're limited by okay, I don't have space here. Let me just say limited hardware resources. So CPU cores, RAM, etc. And of course, CPU, GPU cores, technically both count here. So you have to account for this and make sure you don't overdo this. This is not too difficult for CPU cores specifically, but there are also RAM issues and performance issues. The whole point is to do performance here. There are certain cases where doing concurrency actually slows you down, and I'll describe one of them here. Well, the big one that I'm trying to sort of account for. I'm trying to make this a little bit more presentable here. Just gonna give me a second. Concurrency. So you're limited by that. There's also the issue of actually, is it actually performant, right? The whole point of doing this is to make things fast. But there are cases where doing it actually makes you slow down. And these are scripts. So there are 2 different types of scripts. The scripts is the script init heavy. So init as an initialization, right? So for example, let's say if you want to compute some value based on, you want to extract certain features, but in order to do this math, you have to load a bunch of stuff into memory first, right? You might think that, hey, I have one worker loading stuff into memory and doing one computation at one point in time. Why don't I have 10 of them doing it? Then what happens is that you're loading this resource 10 times, right? If it takes 10 seconds to load the resource before you can compute one file, you don't really want to load that thing every time if your computation only takes like a split second, right? You take 10 seconds to load, you only have a split second, you're incurring that cost multiple times at once. Not to mention, if it's something that big, you'll most likely run out of RAM anyways. So for those scripts, you don't want to have multiple instances like this. What you want instead is to have the loading be done once. I don't know how to draw this actually. What's a good way to draw this? So init, and then this is the processing versus just like no init processing. So for these guys, you don't want to just spam them like back to back to back to back, right? Like if you have like a bunch of shit like this, you're wasting a lot of time here if this is time. So what you want to do instead is to do this, right? You load it once and then you compute it multiple times. So in cases like this, you don't want to spawn multiple concurrent stuff like this because they each have to load their own. And then depending on how big this is, you're gonna run out of RAM because you only have so much RAM. So there are essentially two types of scripts. So the thing has to account for this and be smart about what thing it should spawn and what thing it shouldn't spawn new processes for. And then execution, what else is there? Execution, let me see here. Feature registration resolve requested. Features low incremental state compile signature and validation. Oh yeah, there's a lot of other nonsense here. Load JSON files, initialize checkpoints, logistic insert term, dependency resource aware feature scheduler. For each feature path, decide reuse versus recompute. If recompute is needed, if your current change this, blah blah blah. Okay. Okay, so this is what we have so far. There are more stuff here, for sure. Now we talk about 2C, right? So reuse. So now that we've gone through of like how intense the computation might be, or how complicated it might be, or take a lot of time starting and ending, you want to reuse computation as much as possible. And this is where we come into the idea of checkpointing. So let's say you're running scripts, and then halfway through you crash for whatever reason, and you were processing like let's say you're processing file number 3998 out of 4000 and you crash. Are you going to restart from 0? If you don't want to restart from 0, you need to save your progress, right? Just like a save file. But then, what are you saving? How do you know where you've saved? Every time you start the script, you have to reload where you have saved before, right? What if you save a state for file C, right? But you change the file for A at this point. So now the A computation would change, and therefore your save data here for C would also be invalidated. So the orchestrator needs to be smart and be able to handle this, right? So restart from checkpoint. So let's say A, the 3999 out of 4000 crashes. And then we can maybe like 375 out of 4000 reused. Stuff like that. And then it needs to also be smart enough to invalidate cache. So if A, B, so saved, let's say 4000 out of 4000 saved. And then if you have A prime, B, this is invalidated. And it needs to be recomputed. And of course, like if there's other dependencies, they all have to be redone. Alright, scripts updated. A to A prime, basically. This is the other case, but then there's also another case where the data set is updated. If let's say your image files change, maybe you don't need to delete all 4000. You can reuse 3999, but only do the computation again for the new one. That's it. So there are different cases of reusing. By the way, everything I'm describing so far, the script actually handles it. That's why it's insane. Like this project so far, the structure has been very powerful. It's just that it's not done necessarily in the most clean and organized way. It is still sort of broken up into different scripts and organized by the orchestrator and so on and so forth into different functions. But it is not very clean and clear, that's for sure. So it's a bit of a problem. Let me see, what else does it do? There's also other things sort of related to this. So it is basically sort of we need to make sure we can save to checkpoint. So saving checkpoints. So this is either one periodically by file count. So a file's processed. So this is like saving once every 250 files or something. Oh, sorry, EG. Or it can be by script or script. Or it can be on crash / termination, or SIGIN rather. SIG term. So saving checkpoints needs to be smart as well. So dependency verification, execution, parsing of data, concurrency, reuse and checkpointing. What else is there? Finish run, finish checkpoint, finish output, recomputation, each feature pass, reuse versus recompute, SIG turn, checkpoint machinery. Right. I think this is the main gist of everything that it is doing. It is a lot of stuff that it is doing. The script is over 2,600 lines long, which is why it's so hard to maintain. But also because I don't fully understand it. But this is the idea behind the data processing. So the current issue that I'm facing here is that the concurrency issue is an interesting and tricky one, because there are two types of things to consider here. Number one, we have this initialization heavy scripts versus non-heavy scripts. This is the biggest difference because it depends on whether if you're spawning workers or not. Initialization heavy stuff should not have many workers. In fact, it should probably just have one worker. Whereas the initialization not so heavy ones can rely on multiple workers to expedite the process. And then there's the difference between using CPUs and using GPUs. Because resource is limited, just because you can spawn a bunch of workers or do multiple scripts in sequence doesn't mean you should, because there is a chance that it might cause more lag and cause you to crash potentially too, if you're overusing resources. So the scripts themselves not only need to report the dependency chain, it has to report GPU and CPU usage, I think. So whether if it's a GPU or a CPU heavy script versus... So this JSON format needs to be tied down, right? We need what kind of types of script it is, what name it is. This is basically used on the front end, by the way. This is the name that's over here. You can see the pixel color stats v1 dot the output value here. That's what this is. Pixel color stats v1 and then dot some output value here. The description, the actual script location. You can see there's MJS. It's like a JavaScript thing. That's why the runtime is Node, whereas this one here is Python. Enabled by default just means whether if it runs or not when you start the script orchestrator. And then dependency reporting, input buffer RGBA. So this is the color space that the image data needs to be in. Depending on the color space, the values can be different, which actually probably why things are so weird, actually, now that I think about it. No, but I'm doing math in RGBA anyways, right? Yeah, I am. Okay. The maximum amount of time awarded to running one instance of this file. The execution. So single file. So every time I call this file, I'm expecting it to give me one result. Versus this one, which I pass it all the files, and then it's just going to do its own thing. And then following that, we have a script manages concurrency. So this is who manages the concurrency here. There's an idea here where either the orchestrator does the concurrency because we are expecting the script to just run one thing at a time. So I can have 10 different workers doing one thing at a time. But then if the script is doing like 10 things at a time already, you don't really want 10 workers doing 10 things at a time. And again, why might the script be doing 10 things at a time? Because it might be initialization heavy. So depending on that setting, this orchestrator either does or does not handle concurrency. And so on and so forth. So currently, so my mind is a little bit sort of caught up on this detail here, because we can either pass it one file or all of the files. And then we can also either do one worker or many workers. So I can do... Yeah, this part is the part that I wanted to sort out today. Essentially, we have init heavy. Init, let's just do it this way. Init heavy versus light. Oops. And then versus GPU usage, I think. So GPU or CPU. I don't think it matters in this case, right? So let's say GPU and just CPU here. I want to see which one is bound by here. So if it is heavy, we really don't want to have workers here. We only want one worker here. Regardless if it's GPU or CPU, because the initialization is heavy, right? But it depends on what heavy means in this case. So I think there's an assumption that heavy means you're loading some kind of a computer vision model in order to tell maybe like say what the character's pose is. In which case it will be probably loaded into... It can be loaded into RAM, right? Or it can be loaded into VRAM along with GPU. So... But I think regardless of which one, we probably just want one worker either way. And then in terms of light stuff, then it doesn't really matter if we have eGPU or not. We can have multiple worker. Yeah, I think this is the only sort of distinction here. So for single script. This part might not... This part is going to make a little bit less sense because this part I'm not 100% clear on, so I cannot really present this part as clearly as I would like. Most likely I won't be presenting, I'm just talking about stuff here. So concurrency in script. Concurrency in orchestrator. I see what the problem is. I see. So I was getting very confused because there's too many dimensions to this problem. But so there's like I mentioned previously, there are multiple levels of concurrency here that's in play. Either you have multiple different workers doing different things at the same time, or you have one worker doing multiple things at the same time. And it might be a little bit confusing this way, because at the end of the day, you're still just leveraging different GPU and CPU cores. It's just at what stage of the process you're doing it. Is it in the script itself, or is it by the orchestrator? And also there's another thing to consider is that because the way the dependency chain works, there are chances where you can run multiple different types of scripts at the same time. So you might have a script that's running GPU heavy and a script that's running CPU heavy at the same time to fully leverage all the resources. But the thing is, the orchestrator, in order to do stuff like this, well, either number one has to know, well, it will have to know if it wants to do it well. It needs to know whether if you're doing it, if your script is GPU or CPU bound. So yeah, like, so now the problem is, let's say you have multiple scripts that you want to run at the same time. And because they're all sort of heavy in it, you want to only have one worker. But then you're like, hey, even though you want one worker per script, you can have multiple scripts going at the same time because these are different individual scripts. So you have one worker for each of them. You're not wasting initialization time because you still have to do one initialization at least for one script. But can you run these guys at the same time? Because you are only using the same GPU card at the end. So then maybe there shouldn't be any concurrency in this case, even though potentially you could. That's number one. Number two, another case could be that you have multiple sort of light pieces of work here, right? So you have script A that is very initialization light. You can maybe run 10 workers there. Script B is the same thing, you can run 10 workers. Script C, you can also run 10 workers. But you only have 8 cores. So even though there are 30 workers trying to work at the same time, only 8 of them can work at any point in time anyways. So then we should probably implement some kind of a worker pool. So there will be 8 workers at any point in time, and they will just take a job and they will go. So that's probably the better way to organize this. We limit the number of workers that can be spawned in the first place, and then just delegate work. And then in terms of GPU usage, probably best to not have multiple concurrent GPUs, simply because we are most likely using the entire GPU anyways when we're doing optimization of GPU. So okay, with this it becomes a lot clearer than the logic. I know you guys might not necessarily be the clearest explanation here, but this is the stuff I wanted to work out today because I need to work out the structure here in order to understand how the code flow is going to work. So the orchestrator has to work in a very specific way, I would say. Let me try to write down the flow of the orchestrator here. I can't write anymore. Shit. By the way, I think it's obligatory to mention that this is not really strictly required for what I want to do. This is more like a pet project, but because this has already gotten started and we have everything else ready, other than this one last part, and as well as the scripts themselves, we're pretty close. And I want to at least get like a simple something working better than what we have right now. Maybe the colors can be improved a little bit more to make it a little bit better before I put it on the back burner and go back to drawing, because things are easiest done when you have some idea of what you were doing before, right? If I stop now and I come back later, it's going to be impossible to do. So this is the best time to do it. Even though it seems like we're going on a tangent right now, it will be a lot more of a tangent later. If we do it later. If we don't do it later, then it's sunk cost fallacy, I guess. The time that we spend before is gone. And I will always want to do this anyways. But anyways, so we have the startup. So the startup sequence, I believe, involves sort of going through. Actually, I'm gonna read the other report here because this report isn't very good. ChatGPT has been going downhill quite fast. Python binary checks in order explicit CRI argument environment. So it checks the Python virtual environment here. Sorry, parse CLI, check VENV. And then it does the feature registry. So feature registry wraps from all I'm gonna call it registration here. So inlines, nodes. Sorry, node. I just call it JS. Hi. God. And then cause load external feature manifest. So this is the feature manifest. Sorry, why would it grab the... Oh, I see. Feature manifest and then hashing is script problem and distinction for cache invalidation. Right. So we're checking for cache invalidation at this stage. So inlines then manifest into JS/pi. Both sets are run through register feature, validates, and normalize stuff like so feature registration, cache invalidation. So this is hashing and cache invalidation. And then finally, dependency chain checking. The least features, so I don't care about that. So select features and resolve dependency order. So Pix either explicitly requests the features or all enable the default ones. It recursively pull in any dependent. Okay, so it's doing a depth first search. And then does a topological sort. So DFS with cycle detection, so features run after what they depend on. Loads incremental states if not stat. Tries to load the previous output JSON. So loads incremental. So this is a process data recovery. So after this, it tries to execute. So just before execution, we are checking for checkpoints. So checkpoints are basically the stuff that we processed before, right? And to see if we can reuse those checkpoints. So that would depend on the data set, that would depend on the scripts themselves, the hashes. So that's the incremental state. The persistent feature state directory per feature request, per feature value stores keyed by entity ID plus run an inventory metadata. So that's basically all the other checkpoints. I'm just going to consolidate as under one word checkpoints. So again, this is again more sort of cache invalidations. Invalidations. And then we begin our execution. So we're gonna pull load image files / data. So this part has a bit of a discrepancy. I also need to tie down the interface between all the different scripts here, but that can come later. Determine which features are signature invalidated for each of them. If the signature hash is marked as still and recomputed for all entities, that's fine. Scanner data limited set. Trials are truncated. Files are filtered to only those names match the expected pattern. Okay, so that's just some invalidation. Build entity task list. So for each valid file, entity row is constructed with a stable entity ID, metadata features that will be filled by feature passes. Okay, so it's preparing the final. Features are filtered to only those whose names match the pattern. Files are non-photo variant, everything else some. So some filtering. Build a feature task list. This is interesting because build entity task list, I'm not fully understanding what this point. I guess it is just the final sort of the data structure to store the final version of the code. Sorry, of the data here. Presumably it would be before, right? So complete feature value for task. Worker, sorry, I'm going back up into the thing, right? Oh. Where is that thing then? Oh, I think music died. Request the names and execute the names. Checkpoint node. previous output label, save nonsense, low feature state count. Yeah, I don't know where it is. Let me ask. Lines 2224, 249. There's a stop requested, actually. Yeah, I think the stop requested is for SIGINT. It's interesting. So every row has the stuff in here, metadata, created that, and the features, right? So this is a row. The row gets pushed into entities. And what is entities here? Where the hell is entities defined? Just some random array sitting in the middle of my main, I think. It's like 1,000 lines higher. Holy shit, that's so high up. So I'm gonna assume that this entity is just the final data structure. And pre-populates with some values in there. This is also probably where it's saving and grabbing values from for each scripts and their dependencies. Okay. Whoops. Well, what just happened? Where'd my shit go? Right. What was next? What was I doing? Oh, right here. And I run the feature scheduler as it manages running feature passes concurrently, respecting dependency ordering, resource groups. Right, so that is the limiting. The scheduler loops, so starting any features is being satisfied. And then await promised race on active runs until all completed. Okay, so that's the worker part as well. Where is this dependence? What? Where is it running it? So then this resource groups. New resource group. Where is this? I don't know how the language works. So it's defining this. Makes active resource dot get resource group. If you can't tell, I can't really read JavaScript and TypeScript. Where is my limit defined, actually? Dependence by name, feature name. Wait, what? Why is it? Wait, what? Oh, no, I'm looking at the wrong thing. Oh, I see. It's hard-coded, I think. Sure. I think I might have requested for this, actually. Because at some point it was having issues. Resource groups, the scheduler loops. Per feature extraction. The first pass evaluates every entity to decide whether to recompute or reuse. Oh, okay. Then what was the previous one? I guess it's computed data. Comprehend a little bit? Yeah, I can sort of understand, like, you know, if statements and stuff. There are some sort of language features like this. So you're defining this to be a closure, right? So this thing kind of is like a function. But it's defined like a weird way with this arrow language as well, which I don't really get. Also async and promises doesn't really exist in C. These are asynchronous sort of runs to do concurrency and stuff. It gets a bit confusing. I'm not very used to this. So essentially here is saying that it's going to run this in an asynchronous manner, and then when it's done, it will automatically also run this part of the code. So this will only run when these are done, but because this is defined like this, you can start multiple things, I think, at the same time. And this waits for this as well. I don't know what this is. Feature pass. Here's feature pass. Feature progress. Oops. Yeah, I'm gonna need at least some syntax guides if I were to really read this. I'm trying to avoid reading it because the more I read, the more I am just basically coding at that point, and that's the slowdown. You get more control, of course, right? If my complaint is that the AI is doing dumb shit, then I will have to read it. I will have to figure out what it's doing that doesn't make sense. But ideally, I don't want to do it, if possible. So that's why I want to straighten out the logic that I want. And then I'm just going to ask it, what is it doing? And then I'm going to ask it to make the changes accordingly. That's how we got here, by the way, in the first place. We have like a whole lot of scripts here. If you look at all these scripts, these are the packaging scripts. So we're talking about extracting the useful data and creating all the thumbnails for the front end. And then there are the individual feature scripts over here. There are the Twitter scripts over here. And then there are some other scripts for some other stuff. I think they're not. I think we don't need that many over here. I think this is it. It's quite a lot. Eventually, this thing will become really bloated, this feature scripts, because we will need a lot of them. And the dependency chains currently are very simple, right? We're basically, like this thing that we have set up here, RGB ratio, we're basically depending on like, hey, how many red pixels, blue pixels, green pixels? And then we take the number and then just compute a ratio over the total number of pixels. In fact, you don't even really need this dependency chain in the first place. You can do everything at once, right? Dependency is more for cases where you have either you want to take this pixel value and use by multiple different things, in which case, in our case, you can still kind of not have to do this. Or your script B, for example, let's call it script D, right? Depends on A, B, and C. Then you kind of want to do the dependency because you don't want to put all the logic of A, B, C, D into one script. But in this case, the A here and the B here are can basically be the same script. But anyways, eventually the dependency chain will be very complicated because you can imagine, right? For example, if you want to find out if an art has a blue background, like this has a blue background, but maybe the character isn't that blue, you will need to find out where the character is first. So you will need to run a computer vision script to figure out, hey, where is the character? Create a mask of the bits, of the pixels that is and isn't a character. Then use the clipping mask to be like, oh, background, do some separate computation. For the character, do some other separate computation. And then combine the results at the end. And then you output that. And then we can figure out, hey, is the character dancing against a blue background? That kind of stuff. But anyways, those are not really that necessary. It's just an example of what you can do. But like stuff like this, for example, if you want to have, let's say you want to have a metric of the kind of contrast between the character and the background, then you can do something like that. You can get the pixels for the character and pixels for the background separately, do the math accordingly, compute the contrast values, and then we can have a skill on that instead. So for characters that are highly contrasted against the background, we can find it. But of course, art gets very complicated. You will start having different regions of the character being different colors. And then you have the issues of sort of effectiveness of being able to extract this. I think in all likelihood, we probably wouldn't be able to do too much with the scripts because that part will be really hard. It's like playing an entire game by itself at that point, trying to figure out what kind of logic can get you what kind of outcome. But at the very least, I want to get the structure ready. And we can still do things like, for example, talk about rendering styles, right? Like how complicated is the rendering and how simple is the rendering. Stuff like, I'm trying to not click on something dangerous here, right? But stuff that's more painterly versus stuff that's more sketchy, per se. Or these sketches over here. That we can still do. And I think that's the main goal here. For example, if I have someone who painted like this, can I find someone else who paints in a similar way? It looks really good, actually. Yeah, but anyways, honestly, I don't think we can go too far because the complexity that is required is out there. And like I said, this is probably someone's research project that they would spend like 4 to 10 years of their life on doing like some kind of PhD study somewhere full time. Or maybe not full time, they're probably helping out a professor doing some junk. But you get the point. So create final data struct and then the execute. First pass dependency ordering in order. Sorry, within resource limits. Sorry, within. Scheduler, so looping, execution, first pass evaluates reusing again. I don't know why there's two sets of reuse here. I'm gonna find out. Depending on the feature, single call. So this is the concurrency handling. Checkpointing here. Every so often, right? After some batch of files. The script it's done. Decodes image via sharp. So auto rotate sRGB, RGBA, raw buffer, feature the compute context. Parallel to max workers. All files call are packed into a JSON job file written in temp directory. The external script is invoked with --rmap bash job and must return a JSON result error key by entity ID. Okay, checkpointing after each entry. Yes, that's where we are. Final output. So I guess this is the part where it kind of just loops. Draw a nice circle here. Yeah, and then adjacently there are some other stuff such as the SIGIN and SIGTERM handlers, which are there to sort of figure out if the user wanted to stop it or not. But that's besides the point. I want to check on parse resolve the build feature registry release features resolve. Determine which features are signature invalidated. So difference between the cache invalidation of 7 versus in the execution. Oops. Complexity certificate current signature if they defer the features at a signature invalidated features. This is a blanket invalidated. It means the feature script logic exchange. Every entity needs to be computed regardless of anything else. So it's a blanket cover. This happens inside per entity reuse decision. So entity has no previous value and source path has changed. Image will move or replace. Any feature in this depends on is recomputed. Okay, so it's kind of cool actually. So there's two checks for here. There is the invalidation for entire sort of computed data sets for script versus just a single image. Where is it? Execution reuse here. Single image cache invalidation. Actually, it's kind of impressive how far the script has progressed without any human input. The fact that the logic was managed to be this complicated without me actually physically touching it and actually even instructing on some of these ideas is kind of crazy. Because it works. It's just kind of slow at this point. There are some inefficiencies in the script's operation, which is what I want to figure out. But other than that, all the features mentioned so far and all the complexities are very perfectly handled. The orchestrator is able to start and stop anytime I want it. If it crashes, if I stop it, it will be able to restart where it left off. It reuses data aggressively as much as possible, so all the processing is as fast as possible. So any other caches? Any other cache? Source path, source file path change. Track per entity via source change. Entity class construction. This constructs the current file's relative path against what is recorded. The same entity now maps to a different path. Source is set to true. So this is no different. This is still just step 11. So feature, so that's the entire script. No previous state. Source path change. Dependency was recomputed. Cascading true depends on chain via recomputed features. Okay, yeah, that's like, sure. So there's still only 2 places. Okay, that's fine. So this thing helps me sort out, I think, what I want to sort out. So we'll just enforce that as long as init is heavy. We want 1 worker, and then this is this. So my control knob is just here. So single file call versus all. Well, actually, I got it backwards. Let's split them. Single file call. So I have some settings on the registration here, if you remember. I'm just trying to figure out if some of these are redundant or not. Because there's actually a batch. Yeah, there's like a max worker setting here, but then there's like a max worker setting on the inside. There's also batch numbers which got removed. Oh, sorry, it's just the naming. Anyways, it's very confusing beforehand because there was multiple control knobs doing the same thing, and it was not behaving the way I expected it to. But I think now I'm clear. So that controls whether if you're doing 1 worker or multi-worker, right? Whether concurrency is in script, you get the full list, or whether if it's done in orchestrator, you get single file per script, but you do multiple instances. Then there is the idea of resource management. So this is the resource group. So resource grouping, group / limits. So GPU, 1 script at a time, and then CPU, max core worker pool. Once we implement pools, it becomes a lot easier to understand because you just grab a worker and you go, instead of having to worry about like 10 different scripts running 10 different workers at the same time. It might even be doing that already. So once we have the 2 separation here, we just need to maybe think about if there are cases where we want to have multiple of this and multiple of that, or less of that. Let's not make things too complicated. There are some other optimization issues here. Like for example, every time you open an image file, you have to read it from the system and then load it into memory and then send it to the scripts. Previously, actually, it was optimized by file, right? So this here is the computational timing. So actually, if we talk about optimization here, we need to talk about the execution time, right? The execution time, sorry, processing time. Let's call it feature extraction time. So my lingo is tied up. So we have the how do I draw this? Let me see. So ugly. So here, we need to load from file. So load file, load file, and then this is processing. How should I draw this? Let's do it like this. Processing. And then there's init. And then there's the logic. And then there's the teardown. Right, this is the cleanup. For every script that executes, let's say A, you have this, and you have B. That then repeats this process, essentially. And they have to be done sequentially, because there's no way to do... what should I call this? Execute? And they execute as to clean, actually. I'm going to tie up the terminology here so it's cleaner. So execute, and this is the clean. So the issue here is this load file here. Used to be that we will load one file. So this is the old method, by file. We will load the file once, and then we will run. And then once at the end of the day, we're done. So every file, at the end we save. So this part, this part, this part. At the end we save like that. So this is sort of as little of this as possible you would do. But then now what we're doing is we're doing per script. And the reason for doing this, I'll explain a bit. But let's say we load file. So this is let's say load file number 1. So what we do is we're gonna load file 1. And then this will be file 2. Let's just do it like this. This is easier. Load it to N, and then we'll execute A, potentially in multiple. So what's going to happen is we're going to do it like this. It's going to be multiple entries here. So A1, A2, and then this is AM, let's say. This is our I, our execution, and our cleanup here, and then data consolidation save. So it's a little bit more complicated than this, but this is the kind of thing doing here. What was the reason for changing this was primarily because I'm anticipating that we're gonna have potentially a lot of issues here. So there is so this is CPU worker. What should I call this? Init light. And then versus init heavy. We're gonna load. And then we'll have a singular large init. So only B1. And then we'll execute E1, E2, EN. Actually, this part here most likely will be parallelized like this. I need one more space, so let's say let's do this. E1, E2, EN. Maybe it probably couldn't do all N at once, but just for example, because I don't have space here anymore. And then we save. So the split here was primarily because of this. If we do it in sequence like this, every file incurs one init on B. So every file here will incur one init on here. But if we do it this way, every one of them only incur one, and then we process all of them like this. So we will save a lot more time by not duplicating this part, even though we're duplicating this part between different scripts here. So we can also optimize by keeping these in memory if we have enough memory for 4,000 images, but it's unlikely. But yeah, this is just a trade-off, I think, in terms of optimization. We can either optimize for this part or optimize for this part. Now that I'm thinking about this, this will have to be pretty heavy to overcome this because file I/O isn't very fast. But at least we're on SSDs, so I would say it's better than normal. Oh, that's better than it would have been, I guess, in the past. I think there were some other reasons for this. No, actually, probably this is the main reason for it. They all JPEG? No. I forgot what the filtering said. There's a filter here somewhere, I think. But it's all image file types, supposedly, I think. I don't know where it is, by the way. There's only 6 of these, but I don't know if it's even using this library function, if I'm being honest. So, oh, it's up here. So image extensions that's accepted that we can process: JPEG, PNG, WebP, GIF, TIFF, TIFF, BMP, AVIF. But yeah, anyways, yeah, this got unused. It was very confusing, the script, because there were like batching as well. So there are cases where you can have multiple workers and each one takes a small subset of the files, but there's honestly no point in doing that because you're going to be limited by resources anyways. You might as well just have one giant call and then let the script do it. The main downside to this is that if the script crashes, you lose all progress. But I think I'm okay with that for a little bit more simplicity in terms of the organization here, because it's already complicated enough. But anyways, this is the... I guess I kind of worked out what I wanted to work out. Is that what I wanted to work out? I just wanted to work out what the control options are. So there's 2 limits here. And then beyond that, optimization, we can talk about optimizing the initial loading process and keeping this part so that it doesn't have to be reloaded here. But the thing about optimization is that you only optimize when you truly have to, because you can always try to optimize some stuff. But until everything works properly, it's not worth the effort. And you know, optimization tends to be really specific to your logic. So if you change the logic, you're gonna have to redo optimization too. So it's not worth doing in the early game, which we technically are not in the early game, but yeah. So now what? I spent like 1.5 hours trying to work out this logic and talk about the entire thing and document everything here. I think, oh, that's kind of it for this for now, at least on stream anyways. This is pretty heavy stuff. I need to go back and reevaluate this orchestrator code here. I probably have to change the thing away from ChatGPT because it's kind of bad. I'm gonna link up with Claude maybe, and then we can refactor that code one last time. Then after that, I need to tie down the interface for the scripts. So no matter if it's heavy scripts or light scripts, they need to have the same interface, which is to take in either image data or some kind of file path. I think I'll change it to file path. No, I was using ChatGPT. Actually, everything so far that has been coded was done completely with ChatGPT. And it was really good until like just like recently. I guess it's gotten a lot worse now. It's actually incoherent. Like what it's telling me doesn't make a lot of sense because the way it's phrasing words is very awkward, and it's also not reading stuff correctly, and it's also not pulling enough context, so it's saying the wrong things. So it's just becoming impossible, right? The only way that I can continue without with AI with ChatGPT is to not use it. Actually, I will have to read all 2,400 lines myself and then make changes myself, which will take weeks. We don't have weeks. I want the refactor to be done by this week, and then I want an updated set of scripts here that does the pixel color counting with the thing, and then that will be done. So this is 2K lines, but I believe there's like a couple hundred lines that were moved out at some point in time. I forgot what for. There were some issues with the thing. They got moved out. There's also the packaging scripts. So these are responsible for building the thumbnails. So this is the thumbnail atlas. So if you look at the website, right? We obviously have like thousands of files here, but we're not sending thousands of files to the front end, because that would be a lot of cost and a lot of overhead. So instead of sending like 4,000 files, we're sending like 100 files, if I remember correctly. Because what they're doing is that they're actually compiling a bunch of thumbnails into a singular image, and then they're sending that instead. Let me see if I can find it here. This one. Yeah, it looks like this. So this is like one thing. I don't know if there's anything explicit here, so I'm not gonna keep it on for too long. But this is what is being sent to the front, and then it gets extracted out into individual items here. So we have like this many, and also of different quality as well, right? Because you want to make sure that when you're zooming here and there, there's a lot of optimization for speed. Blah blah blah. The features look kind of like this. They're just giant as JSON files with like lines of lines and lines and lines of data here. So you can see the number of entries here, about 5,000. Which doesn't make sense. I don't think we have 5,000. Anyways, I don't know why there's 5,000 lines here. I have no idea what's happening. Yeah, have you not seen this, George? I've showcased this a few times on stream, but most of the time people are not here. This thing is pretty cool. So click on this. Click on this, you can zoom in and out, just like my own website, right? You can apply filters, so you can do more sort of analysis this way. Eventually, we can invert the colors, we can add on. So if you notice, it's not blue, right? It's still in that feature because it's stacking on the effects. I can remove that, and then we'll go back to inverting the original colors, which is blue, right? Becoming yellow, and then the white becoming black in the back. There's a lot of cool stuff. You can reset, you can remove this, you can turn it off. Like that. It's very intuitive. You can click wherever, like click outside, it's gone. You click here, it's here. And then over here, you have the ability to search for artist name. So I can search by this artist. You see that they did other stuff. It pans over. I'm just going to zoom out because I don't know if there's anything, again, explicit. It's the same artist, same art. You can zoom over here. It's over here. Something else here. Oh, cool. You know, more art. You can also go back to the previous one. And you notice there's a bunch of different ones with different colors, and they're all at different spots because they are. This is red, it's in the red area. This is blue, it's in the blue area. This is green, it's in the white area because it doesn't have neither of those pixels. So yeah, there's like a lot of quality of life stuff. You can also favorite stuff, and they will show it in a separate list at the bottom. So you can always find your favorites. Like I can refresh the page. I can find my favorites. It's right here. Look at that. I can also unfavorite it. I can also hide it. It's hidden like this, but I can also make it invisible, so it's not there anymore. This is mostly implemented because I wanted to hide all the explicit stuff and have a default hide list, which is not implemented yet. You can search by tweets, you can search by artist handle, like we've seen before. You can also search by text, you can search for ASDF. Apparently this tweet has ASD in it. Where is the text? I don't know where the tag is. Oh, the text is here, it's just a link. So it has ASD in the link. You can open the original post here. As long as the post is not taken down, you can open it. You can find the artist you want. Everything is accountable. Everything is sourced correctly. It's just great. Like it's actually kind of insane. And then you can upload stuff. This thing here is extremely slow because the orchestrator is doing some weird stuff. I'm pretty sure. Like this part takes like 10-15 minutes to run. It used to only take like 2 or 3 minutes. So something is very bad is going on in the background. But I digress, right? So eventually I'm hoping that we can dig into stuff like this. But honestly, a lot of this is kind of like the chicken and the egg kind of problem. Like, because in order for me to create something that is good and useful and is actually sort of able to enable artists to do analysis, I kind of have to be a good artist myself. I have to be able to understand that what artists are looking for in the first place, right? And then translate it into math, and then create the scripts. And then we can do it in an organizational manner. Oh, this is done now. You can see once it's done, it actually tells you where it is. I'm gonna unpack this. But the issue is that by the time that I can do that comfortably, I am done with this. I don't need it anymore because intuitively I can already do it myself. I don't know why that takes so long. It doesn't usually take so long to compute. So it's like right here. And, you know, logically it's meant to say that, hey, the things around it, you know, is similar to this art that you have uploaded. You can find stuff that supposedly is, you know, similar, but I don't know by what means it is similar. I mean, I do know actually. It's actually written here. It's blue light pixel count. Actually, if we find, like, let's say we use this instead. Let's say we upload something else. Let's delete this. Let's say we use something that's a little bit more colored, because right now my thing only accounts for color. Let's see. Something red like this, perhaps. Oh, it's so much faster now. Why? The first run is so slow. Okay then, I guess. Blue light is not very good. Let's do red. It's actually kind of useless. I don't know why this is marked as red. Apparently a lot of red. Must be the jacket. I don't know. So you can see right now it doesn't really work necessarily that well, because sometimes it ignores the white pixel. Well, it's my logic. I made it ignore white pixels because it could be background, right? But ideally, the thing is smart enough to know that, hey, this part is just a background. You can ignore it if you only want to look at character. But if you want to look at it as a whole, you can also account for it. So ideally, it's smart enough to do that. Actually, this is way smoother than my my website right now, actually. I spent some time yesterday setting up this new domain. I updated the title here. And then, like, these guys here are not as smooth, I feel like. Like, this is kind of fast. I don't know, it's kind of okay, I guess. It's about the same. There's a bit of screen tearing, I think. Because we're not VSync. But that's more of a browser and a us problem rather than a website problem. But anyways, yeah, I would like to be able to take this and be like, hey, find me similar artists with similar shapes. You know, if it's able to identify a big shape here or a shape there, that would be kind of cool. Mathematically, I don't know how it's gonna be done, honestly. Like, it's kind of insane, actually, what we want to achieve here. The potential is very, very good, but, like, it's just no skill. This is a separate set of skill, for sure. And also, you can clearly see the math is not very useful here. Like, this doesn't even have anything red, though. Why is this reported as being similar in a red light pixel count? There's no red here, dude. What? This has way more reds, surely. Unless it's not saturated enough to count. But that doesn't make sense. This is pretty saturated red. But anyways, this is the brief sort of overview, George, of what's happening here. And also, I just feel like I should mention again, this is not AI training. This is nowhere close to AI training. This is just trying to group stuff by relationships, so we can look at them a little bit more objectively, rather than being very subjective every time. Because if you can objectively compute some value, then you can be a little bit more consistent. But the issue with that idea is that the computation itself is a little bit subjectively determined, right? Like, for example, we are talking about the blue light pixels. What is considered blue light, right? Specifically, you have to choose a number where it stops being blue, but you're choosing it subjectively. So it is still somewhat subjective, but it will be a consistently subjective evaluation, because every time we are evaluating with the same thresholds like we did before, we're not going to be affected by mood, but it's still kind of pretty subjective. But art is also pretty subjective, so you can't really stray too far away from it, I suppose. Anyways, it's a huge mess. Don't worry about it. Yeah, why is this so much faster? Maybe this image is huge or something. No, it's 800 pixels, bro. What? Let me try something green. It's so fast. It's so fast now. Only the first one's slow. Why though? You see, it's actually managed to found the same thing. But you also notice that the algorithm that we use to sort of place them still place them somewhat far apart. They're not on top of each other, which is very interesting if you think about it. But if you look at the thumbnail as well, this is kind of squished and this is not. So there might be some weird logic in the back that's causing issues. But I digress. I don't know why the next thing is here. Actually, if we go to green light pixel count, let me just apply this. Actually, let me put both on green. Doesn't do anything, bro. Thing sucks, bro. Yo, who made this shit? This sucks. Look, shit's over here, and the original is over here. Whatever, man. Oh, and the similarity actually placed them right next to each other. Yeah, so at least the display size is consistent with itself. It's just not very consistent with what I'm expecting, but try first one. Oh, that's a really good idea, Birch. You see, there's a great programming mind. It's fast now, so there's some initialization costs here. Actually, let's refresh the website and do it again. I'm gonna control F5 refresh. And no, it's fast again. So, is it a warm-up on the... I have no idea, actually. I don't know it that well enough to really know where the issue might be. I don't think the problem is solved. Let me restart the web server. So right now it's down. You can see it takes a while to load here. I'm gonna restart. Is what is indeed. It's fast again. Okay. I don't know. I guess we don't have to optimize anything. But then the computation here is also kind of slow. Maybe it's just a resource thing? OBS choking me up? I hope not. Oh. But yeah, it's an interesting project for sure. Why do I have another button here? I just realized. I have two buttons here. I just need to remove this. Reset the view. It's not clustering, doesn't even work. Why is this recomputing? I guess it didn't cache it? I thought it cached it. Alright, it's whatever. It is what it is. Anyways, that's most of what today was for. Just kind of a sort of straightening out the logic and figuring out what I want. I'm kind of tired now. Oh my god, I've been trying to rush shit at work as well, and it's taking forever. Everything is taking forever. And the worst thing is I don't know if what I'm doing is right? So I was also scope creeping at work, so I'm not doing stuff that was initially planned to be done. I start to recognize that there's a problem where I'm unable to compromise on certain things because in my mind it doesn't feel like I'm doing anything anymore. If you tell me to just do A, B, C, D, E, if I think that like HIJK is required for this to be a complete thing, like for it to actually make sense, I don't mean like I need to add in a bunch of features for it to be finished. I just mean like certain things like you have to organize the code a bit better. You have to organize your variables a bit better. Check out the lifespans and make sure things are done correctly. It takes time, right? It still takes time. Which if you're in a time crunch, you can't allow that. But at the same time, if you don't do it, then what's the point, right? You're making a mess that someone else has to clean up. Most likely yourself, by the way, right? You're assigned to make it in the first place. You'll be assigned to fix it. So like, why not do it right the first time? Spend a bit more time. But as a result, like there's a lot more changes that's required. At least in my case, in this specific task that I was doing at work. And I don't know, man. Like it's some choices you also don't really know you have to make until you start making changes, and then you realize you have to refactor things a different way, and then you have to change certain other things, and then the life cycles have to change again, and then that changes other things that depends on it. And then it's just a mess. And then at the end of the day, the problem is that no one asked you to do it, right? So now you have to justify spending all this time. And a good chunk of time is because you're not skillful enough to foresee certain issues. And then now there's a skill issue. Now you're not very good at your job. And then now there's some other problems. So anyways, I digress. We'll find out by the end of the week whether if things make sense or not. You can't really do that for programming though. I don't think he says that though. At least not many times. Maybe just once at most. I don't recall any instance of him saying it at all. So oh yeah, I'm pretty tired. Yeah, sure. I'm tired, but I'm tired to the point where I don't want to do anything. I just kind of sit here. We are making good progress, right? Like a lot of these things, like everything that we described today, by the way, was done in a week. It was done in a week when I was working, doing my work and then doing our stream stuff, right? And this was going on in the background. The fact that it came together in a week without me writing code is insanely impressive. The fact that everything works as well as it does. But to bring it home, I don't think it's a one-person job. I don't think it's a me-person job, actually. The expertise that's required is very specialized. I have to say. I don't think I have the energy to really draw anything good. I would say definitely I won't be able to. Let me see. I won't be able to continue anything we have done so far. Kind of dizzy from talking. Because you kind of are like exhaling a lot when you're talking. Let me take a look. The thing about there's two parts to this, right? First of all is that unless I finish it and make it effective, everything is sunk costs. Everything is just wasted work. Unless I can bring it home here. But to bring it home is, you know, as you can imagine, the last 20% is exponentially difficult. But in this case, it's the 100% of the script part. It's very difficult. Because it's not just about figuring out algorithm, it's also figuring about a good subjective threshold, like I mentioned. Like, what is blue light pixel? You have to find a good enough threshold that will make they presented data present in a way that makes sense. But then when you change the data set, this threshold naturally changes too. So it becomes like an ongoing process. So that's a lot of work. Number two, you mentioned helping other artists. I'm kind of not sure if I should publish this directly. Number one is a cost problem. There's a lot of costs to hosting a website like this. Primarily, it's about sending and the data back and forth. That's a lot of bandwidth. The second part is that you have a lot of server requirement to handle all the images and stuff as well. So the throughput is a problem. The server cost is a problem, but this is a cost problem. There's a separate vector problem where if this is really, really effective, think of it like this, right? If you have a tool that's really good at classifying images like this, someone is going to use it to train AI. I'm not going to do it because I don't want it to do it. But if someone else can upload an image and start figuring out different sort of patterns in art, can't they just then use this to train AI better? So that's the other concern that I have. And of course, this is a big if, right? And this hinges on the premise that your website actually fucking works. But if the XF doesn't work, so there's also no point talking about it. So it's a valid premise, I say. As hard as it is to achieve, it is a valid premise to have in the discussion. But this is all way down the line. This was primarily created for just for us to use on stream. That was the whole point of this. And at most, like down the line, I can actually open this up as like a supporters only kind of thing, right? This would actually provide some value to you guys, and also provide some cost to myself. So as a result, there can be some trade exchange of financial value in that regard, right? You guys can subscribe to use this thing, and it will just be open to you guys. It will not be open to like public. I mean, it is kind of public, but in the sense that like there is a difference between isolating it to just our Discord and limiting it to active viewers versus having it be just like an actual subscription service that anyone can use. I mean, it sounds a little bit arrogant, I think, to think that like something that I create can impact people to the point where like it's like, oh, this is training AI, it's going to ruin more artists' lives, right? It sounds a bit arrogant to think of it like that, but if you don't think of it now, when it happens, if it happens, what then, right? Anyways, a lot of this huge mess, a lot of problems. I just saw something a little bit not very safe for work here somehow. There are two more things that I can do actually today. One thing is I can go through all these explicit images in the back. I can ask it to add a feature so that we can start creating a list of explicit images to be filtered out. And the other thing is to actually populate our block over here because our block still remains undone. I need to write the documents. They're all a lot of work, I have to say. This is all... If I spend the rest of the week just on stream doing all of these things, we still would not be done. There is so much work to be done. If we want to just get it to somewhere that is decent. Not complete, just decent. So yeah, it's a lot of stuff that I'm biting off right now, and I'm feeling a lot more overwhelmed than the live 2D thing. Especially because work is also packing onto this right now in this current time frame. But we'll manage. We'll get out of this with something to be proud of. I'm sure. Yeah, it's just a matter of time, and then working at it. It would be nice, you know, to like have more people on board with the project, but being a maintainer is also a work in and of itself, right? Because then I'll actually have to start reading and understanding code, which is a problem, because that's what I'm trying to avoid doing. That's how we got this far. I can't read code. But I'm kind of dizzy. Maybe I should let me think. I need a way to but even if I have a way to sort of filter out the explicit, you see over here, right? One of the metric is called skin light pixel count, because I wanted the code like I wanted this to be a little bit smart in like, because if it's explicit it tends to have a lot of skin, right? So I can just filter out those images that way. But you know, unless I go through everything manually, I cannot be sure. So that means at least 24 hours of actual work to go through the images. It's a bit better than before when I have to save images, because if I can set up the UI, all I have to do is click a button, right? I just click hide. I click hide and I check out my cookies in the browser, extract that, save it locally, have it as a permanent list, and then we're done. But I do have to go through this, and this is not particularly easy to go through. There is a square option, so I can actually go through this instead. It's a little bit more structured and formatted, but if I'm like here somewhere in the middle, I'm just gonna be lost. But it'd be pretty quick, I imagine. I can just stay here and click. I kind of have to do it. Actually, yeah. I am putting it off because I'm wondering if I can just not do it, but I think I kind of have to do it regardless. Even if I have a metric, it's not gonna be smart enough. Even if I use a smart enough model to look at it, I wouldn't trust it enough. So I'm still gonna have to do it manually. At least once. And then we can figure that out somehow. Oh, I can do that. I can do the block. How many entries do I have for the block actually? Let's see. Sure, dude. Sure, George. By all means. I wonder if they're not here, they just saw that I'm doing coding and then they left. Which is, by the way, 100% what I recommend doing. If you're drawing it, you need to, and you should concentrate if you're drawing. You shouldn't be here. Alright, thank you, George. I know who this is. I know who this is. This is one of my favorite artists because of the way they do, sorry. Where the hell did they go? I recognize the name. because of the way they did the colors for that one specific one that I like, which is somewhere here. I don't know where it is. God damn it, where is it? Have they drawn this many new things? I don't remember seeing a lot of these things before. But yeah, anyways, I guess I just ignore that. Let's see what new stuff they got. Because their main thing is just colors for me. The way they use colors is very good. YouTube Live. I think it's probably this one, right? That I was talking about? YouTube Shorts. Live. Yeah, let me mute it. No jump scare here. Oh, it's black and white first. What is this layer? Is it a normal layer? What? No, that's not a normal layer. It's either not a normal layer or not a normal brush. It is normal layer setting, it says here in Japanese. But you can see how the brushes go over the values here. Oh, sorry, it's overlay in the folder. Okay, so overlay folder. I mean, this is already kind of a bit of a problem. In the sense that, like, you know, how do you know this is the color you want? I guess they do have the light layer entirely isolated by itself. And I think we can take away that it's not touching any of the shadow colors either. And then, okay, so that is just a flat blue layer just now. This is more gradient on the black and white. Okay. Transparency on the hair. So individual parts here are being put in. Where did the orange go, actually? It might be the one on top. I think it's folder 8. So folder 5 is the individual parts. You know, the irony is that, like, a lot of times, like, these kind of very structured approach is meant to be easier to execute and copy. But because of the sheer number of layers, it's actually harder to sort of capture from, like, a time-lapse like this. Whereas if you just directly paint, it's a little bit more intuitive, and you can figure out, hey, oh, they're just putting in this color on a layer on top. It's an additive process, just paint, you know. Whereas in this case, we kind of have a lot of layer modes and a lot of different things kind of going around. I'm sure with the explanation, it might be a little bit easier to understand. Maybe I will turn that on and just keep it a little bit more soft here. Let me just make sure this is soft before I move. You said they explained? They're explaining your words? Yeah, I see. So this is pretty... this makes a lot of sense, right? Black and white in the bottom, overlay to apply colors. First, there's some consistent sort of... so folder 8, if you notice, if you go back here, this is the lighting overlay. So this is trying to keep the lighting colors a little bit more consistent. Oh, so different ones on YouTube Live. Okay, thank you, George. I'm not sure what YouTube Live is, but I will check it out. So we already have... sorry. So the black and white is at the bottom, and it's on normal. It's on normal mode over here. It's clipped here, most likely clipped onto the base sort of shape for the entire character, so it's on a separate mask. And then we have the lighting sort of consistency layer here. Is trying to make sure that anything that's hit by the light is consistent. So it goes across parts that might be different colored, but it's applying a consistent color on top. Then at some point there was a really quick flash here where they added a shadow color right here. You can see a new layer is added as blue. And this only goes on anything that isn't already colored by the thing, as you can see by the selection. From there on, they turn on the individual parts color. So these are the base colors for each part, and you can see it's split by different base color. But because it's applied, is overlaid by the lighting color here, they stay a little bit more consistent. This is minor adjustments to the values. And then there's just a lot of tweaking. You can see the numbers jumping around, and as well as these gradients going in. to sort of just group more colors together, and more colors and more vibrance. And then at some point, just paint over. Everything's on top. You can see overlay here. This is the adjustment. This is the oh, sorry, the text box might be blocking a lot of stuff. But the base color folder, then the overlay, the light adjustment folder, then there's a bunch of normal layers up top, and this is just paint over. So it makes a lot of sense. Like, this workflow makes a lot of sense. We don't really need to pause too much to really dig too hard at the folder structure here, layer structure. Because we already got it. Just from own experience, I think, looking at this kind of stuff. Overall, I don't know what this is. So we're still doing paint overs here. Why did my folder number change? Really nice. Oh, did they collapse everything? Oh, wait. No, they I think... Oh, folder 3. Oh, it's just in the folder. So this is in folder 3. Everything's in folder 3. They collapsed the folder 3 itself. So folder 9 is the overlay stuff. Folder 3 is the paint over stuff. Folder 4, I'm not sure. Folder 11 is likely line art. No, it's actually this nonsense. Actually, where is line art then? Is line art bottom? Huh. That would be interesting, actually. Can check it out later. Oh, this is just planning the spiky spikes. Okay, great. Is this just entirely painted in? Oh, I see. Did they do... I think they did a... Yeah, they did a... what do you call it? A border effect on the thing? Oh, yes. Thank you, George. I'll check that out in a bit. What is this? Oh, it's painting over each separate part. So this is my usual, what I'm more used to, right? You're clipping masks on each individual thing. Just more painting. More painting. Let me just go. Sorry, I'm going back and forth a lot. I'm just trying to see the folders here. Folder 3, folder 4. This is more painting on top. The hair. Going back to the bottom, painting the hair that's behind everything else. Also just painting. At this point, I don't imagine there'll be anything too different. Because once the colors are set and you're starting to paint over like this, you pretty much wouldn't be changing the colors. With the previous folders, you'll most likely be doing an additive process because it will be invalidating a lot of the paint over otherwise. Just normal painting. Pretty much, yeah. The only thing left would be final sort of post-processing effects, if there are any. But I don't think there are any because it's already pretty vibrant here. Two hours long. Yeah.
これちょっと難しいな。桜って緑なんだよな。私の中で。緑と赤茶。この辺、これの色のイメージに。
Yeah, this has some. So I think layers I'm fine, but if they talk about colors, that would be nice. I think finally, someone like one of these artists that we do like is actually explaining colors and stuff like that. Like, they don't have to explain color theory, right? All they need to explain is why they chose certain colors. But I think, yeah, I don't know. I think you can gain stuff from like watching and talking to some of these artists. But I think at the end of the day, the way you learn the most is still just by doing it yourself, giving it a try. Oh, this one's the one that I was looking for. I like this color the most. Where is it? How they don't have like the other ones? 2024. Oh man, I'm so tired. This one here. There are certain things that always are in my mind. That comes up in my mind. One of them is being asked on stream whether if having so much to do is overwhelming. And I always wondered, because I never really considered it, hey, I have a lot of things to do, and I'm unable to do it because of that. I can't do things because I'm just way too tired. I'm a little bit too burned out from that. But I never sort of just get burnt out by the thought of it. It is through doing it that I get too tired, I guess. But maybe that is being overwhelmed. That is being too tired. That is being burnt out by thinking. Maybe it's the same thing. I don't know. But yeah, I really like this one because of the orange here against the purple. This is such a nice vibrant color here. And of course against the blue backdrop. But also just in general, like the way the shapes are grouped, the cleanliness. I think maybe the hair would have grouped a little bit more. But at the same time, there is a quality that's supported by something a little bit messier, a little bit more defined here, rather than something with big shapes, you know. The use of the black here as well. This is yeah, the blurring, the subtle blurring, the subtle amount of sort of chromatic aberration. There is nothing to disagree with, honestly, with the pieces that they have here. This one isn't necessarily as nice, I feel like. Some of the stuff looks a little bit flatter. Yeah, it's nice. Sometimes I look at this and I'm wondering, like, if what I'm doing makes sense, right? I feel like we've been through talking about this before. It's like if I just want to create my own world and story, shouldn't I just paint, right? Don't worry so much about all these other technologies. Don't worry so much about like different ways of presenting stuff, because I don't even have like the very basis of stuff set up yet, right? We don't even have like a world design. We don't even have a design language or characters established. None of those things are ready. So why are we worrying about stuff like setting up a website? Why are we worrying about setting up like an analysis engine when all we should be doing is just go through the iterations? I don't know. It's a good question. Maybe I'm not like 100% convinced by something or something. I don't know what. Like I am actually kind of confused. But right now I might just be too tired to do analysis anymore. But it is interesting, I think. From an onlooker, I imagine this is kind of confusing. Like whatever the hell is this guy doing? You know, he started off as an Arknight's study guy. He talked about doing his own thing. I released the character, pretty much never draw her for quite a while. Actually, I guess we were kind of working on Faye the whole time, technically. Started doing stupid ass websites, started making analysis engines that doesn't work that well. Did live 2D, did some animation, burned himself out like a fucking idiot. And still can't do like some basic anatomy stuff. That's how I see myself right now. Kind of stupid. Everything is just kind of stupid. Sorry, George. I forgot to give you the same acknowledgement with the tweet. Sorry, not the tweet. The sending of the links here. But yeah. Sorry, I'm definitely more negative today just because I'm too tired to be more positive. But this is how I feel. This is how I truly feel. I feel like the thing for me is that like everything is results oriented in this world, right? Like I'm not producing results. what we have are a lot of work done. And I guess strictly speaking, you can call them results, but like results, once again, you need to have an objective. You need to frame it against something. And if the objective here is to work towards your goal, I don't really know. You can one way or another sort of frame it in a way where it is, yes, you are working towards your goal, I am working towards my goal, but it is not the main thing that we should be concerned with at this point in time. Right? We were talking about like if you have different goals and therefore you can be working on different things. It's literally right here. But there are always more main and more important ones and less important goals, right? So I don't know, man. I am I'm not sure. I think I'm not sure. Currently, we're probably just way too tired to process anymore. Yeah. Work is very draining just because of the amount of stuff that I'm... The nature of the thing you're doing, right? There are certain work things that even if you're too swamped, everything is a very individual small task. You know, you can pick it up and put it down pretty easily. But because this task specifically requires you to change things and keep things consistent across 50 different files, you kind of have to keep everything in your head, which is why it's very hard to do. It's very hard to do, very hard to do well. It's also a lot more draining that way. But it's interesting actually. From the same artist, there's stuff that I like and stuff that I don't like. This one I don't like the colors. It becomes a little bit too faded, like the legs against the water. You can see it, but like, I feel like something's missing. As opposed to the other ones, which are a lot more agreeable somehow. Actually, staring at this today, I definitely want to incorporate more of this. But like effects like this really only stand out if you are actually polishing the image though. If you actually go all the way and finish polishing it. If you're doing like a quick color sketch, if you're doing like something that is a little bit rougher, this doesn't really tend to work because the value that this provides, right, is the contrast that it provides, right? Anything about art is about contrast. In this case, the contrast is this blurring effect. The sort of blurring between an actual border of an object against the background, as well as the chromatic aberration. Chromatic aberration's value is the color contrast, the hues that is being provided. But think of it like this. If you're painting in a very sort of painterly style, in a very vibrant, sort of messy sort of colors, then your edges tend to already be kind of messed up, and you also tend to have a lot of colors. And as a result, something like this would stand out a lot less. The reason this stands out more is because everything else is so tight, relatively speaking. And then you have this blurring. So like, I think inherently it means that you kind of have to bring the piece a little bit further in, like a little bit more polished before something like this can truly shine. And that takes more time. That takes more effort. So yeah, that's very interesting. But I do like it a lot. I think we might have done it before in the future. In the past. God damn it, dude. But yeah. Thank you, George. I'm pretty sure, by the way, the piece that we were looking at, the one with the blue one with the orange on the legs, is actually in this list here somewhere. We might be able to find it, actually, if I do blue light. And I'm just gonna go back to Gridlock. It's probably here somewhere. Oh, actually, it's probably blue light and green light, right? Is both? So what does that mean then? Does it mean it's in here? Oh, it's here. Dang it, dude. I actually found it. Look at that. Hug. Yeah, to be honest, I guess I see this a little bit better than you guys because I can lean in a little bit easier to my tablet, but I'm recognizing the pattern that I have. That it has, goddammit. And then eventually, hopefully, we can have filters of like, hey, what colors we want to filter for. We can look at those colors only. Actually, how would I break it down with this thing, right? Because some things you can already just see. You don't really need help with it, you know? But if you want to maybe examine the blurring of this a little bit closer, maybe there are algorithms that helps you find like the edge, like edge detection, for example. What does this look like under edge detection versus here? Maybe the edges here are cleaner. Maybe if I just keep adding edges, it becomes clearer. Maybe not. I don't know. So this is the part where it's like kind of tricky. Because like what actually helps you and what actually doesn't help you, you know? Also, I'm noticing all these stuff in the back. What is that? Oh, it's the particles. Oh, so with this you can check for particle distribution. You can see where the particles are. Previously it's a bit harder to see, but now it's a bit easier to see. Also, I realized this is like a really tiny window, even though it has some extra space here and there. Kind of cumbersome. You can kind of examine the distribution of the particles. And the interesting thing would be to see if there's other arts by them in here. I do have other arts of them in here, and you can apply the same filter. By the way, the filter stays, right? So if you apply a series of filters, it stays, and you can go across images easily this way. And then there are these paddles, I guess. So in these cases here, we don't really get particles, we just get these bigger pieces of detail. We don't have the same type of particles as before. There are some over here, very tiny particles here, but for the most part it's different. And then what are these faint objects here? I guess just different values, like lower value contrast. Yeah, it's interesting, I guess, but that's about it. I don't know if we truly learn anything. But yes, thank you, George. Good stuff today, mostly just talking. I guess even if I'm tired, I can still talk about shit. Of course, we don't just want to be talking about shit, though. I see. The shapes are not as well defined, I think, compared to some other. That's why I don't like them as much. Because even the other ones, as noisy as they are with some of the shapes, it's still very clearly defined. The values are not necessarily that grouped together. Whereas this one, like, the values are just kind of faded into each other here. You can't really see this edge very clearly here. Doesn't that inherently mean that some choices are limited? But anyways, kind of it, I guess. I ate like half a cabbage for dinner. It's 12 p.m. now. 12 a.m. now. I need to go get some more food, I suppose. Dang, another long day ahead. I don't know what I'll be doing tomorrow. More likely than not. How? A bit of a heavier lunch, I would say, but I still ate it at 1 though. I ate it at like 12:31 p.m. But primarily it's just you don't really have any appetite if you're really hungry. Oh, sorry, if you're really tired, and then and you're really swamped with work. Your mind just really isn't thinking about the hunger. But I digress. Anyways, tomorrow's most likely, I think I'll just be writing documents rather than actually drawing again. Or just continue with just cleaning up, getting all of these things off my plate. The faster we can get them off, the faster I can just be a little bit more relaxed and have the capacity to actually do art. I think there's a good chance that I might have to drop the complex piece for now. Kinda sucks, but unlike the Live 2D one, I have much higher confidence that we'll return to it, just because it is a lot more aligned to the goal rather than not. It's what I say though, but like technically Live 2D is also another way of presenting your character's ideas, right? Your character design ideas, because you're bringing the character to life, and as a result, it is just a way of presenting too. So I suppose, you know, like actually they're all the same. But I think it's more interesting, the website, the Faye idea. Did I write anything today? I might as well save it. But so I've mentioned this before. I think aesthetic stuff we will have to do ourselves, right? We definitely have to do the drawing ourselves. But the rigging, the splitting of the parts into different layers, and then the rigging, the splitting we might be able to do it for ourselves. But if we're gonna get someone else to do the rigging anyways, then they might as well do it because they know what they need, right? Even if we do it, we might do it wrong and stuff. So might as well just pay someone else to do it anyways. So we'll probably just find someone. Actually, there's another thing that's on my plate. Actually, there are a lot of other things like bots, like the Discord bot that we have is a little bit janky recently. I should investigate because it could potentially mean losing a lot of like statistics data that we've collected so far. The good thing is that it's in the chat, right? So we do have a copy of it, but I don't know like what's happening with the event organization, if there's anyone having any issues. You know, there's never ending work to be done, honestly. So yeah, I'm not sure. If I can hire someone, that would be great. But you have to stay aligned, you know. Your ideas and goals have to be aligned at all times because things always come up, new challenges always come up. You do one thing and then you realize there's this other thing you have to deal with, and this new thing most likely we will have never discussed. Before about. So you need people with similar ideas to make sure that whatever time and effort that they spend on, it is correct. With the bot, I don't mind, George. I definitely trust you enough to work on it. Even if you don't produce any results, that's also completely fine, right? But the issue with this is that I need to... I'm not sure what's the best way for you to work on it is. So essentially what's happening is that... shit, where is it? Script. Bot. This is the bot script. So essentially it's split into different components here. You might think that it's pretty well organized. I assure you it is not. But what's happening is that, let's say for example, if you look at the Discord here, the recent problems that we've been facing, specifically with this, is that in the past it always edits the old message, right? You can see that it's added here. Let's take this check-in for example. On this day at 5:55 p.m. it did its last check-in, and then if you look at the next message it sent, it's at 6:55. It's supposed to update this to say 6:55, but for whatever reason it's unable to access that message, and therefore it wrote this. And then later on it failed again. Did it fail again? Wait, what date was this? March 10th? Oh, it didn't fail yet. So the way that this works is that the code over here, where is it? Hourly timestamp. So hourly timestamp here is looking at a specific channel ID. So if you look at the channel ID here, this channel has an ID here. This channel ID is this channel ID, and there's a message ID here. It currently is set to 0, because what is happening is that when the code starts up, it looks for this file on the server. If the file exists, it contains the ID. It will override this ID, and then this ID will be used to fetch a message. So you can see that it will try to fetch a message using the message ID. And I think what happens is that this ID probably failed. It's either not found or not editable. It could be that there's a limit to the editing that we can do. Actually, maybe this is the case. Actually, let me just go into the server real quick and check. This is a good chance that that is the case, because I don't think it is unable to access the message. I think it's probably unable to edit the message. Actually, I never considered that. That is a pretty likely chance that that is the case. Sorry, let me move this over. This is Robodaki programming at its best. That is a perfect example, right? Because this is precisely why you do it. Because when you talk it out, you kind of have some better idea of why things might or might not work. I do have to find my README though. I forgot how to do it. Shit. There's a note here that teaches you how to update and do certain things. So when you come back in, you have to do tmux, right? Tmux. So there's a tmux bot, a attached to the bot window. And shit. It's already attached to stuff. Control B, then B. Sorry. Where is my... Did I write it to a log file? Okay, this is pretty bad. I don't have a log file here. So yeah, I have no idea, actually. I think there's a good chance that that is the case. Actually, let me check. What about the other message that was repeated? Oops. So we have this, right? And then we have this, and then this again. So actually, it's probably some timeout issue then. Because you see this repeated 3 more times instead of just twice. So this is probably not an editing limit problem. This is probably just literally having issues. Actually, it's always top 10 VCR time, top 10 VCR time. There's top 67 counts. Oh, wait. Hang on. Can I try to trigger this? But I think it's possible that okay, let me try and trigger this. I don't see any issues on the logs. The logs is not reporting any issues here. But because I am not, yeah, George, yeah, please try, because you're actually on the board. I'm not on the, yeah, okay, it went up 77 to 78. I don't know. It's honestly hard to say. Like, it went up to 79 now, and I don't see any issues on my logging here. Although I don't know if this is the correct logging. Chart ID none has successfully resumed the session. Maybe I should ask Claude what this is actually. I don't know what this reporting is. But anyways, thank you, George. It's fine then. I don't really know how you can help is the thing in this case. Because it's very intermittent. In fact, there's not much that you can do. Rather, I should be adding logging to the scripts and just letting it run. And then until the next time it happens, I will check the logging and then we do debugging this way. Because currently there's no good way to to replicate the problem here. Yeah. Yeah, no, thank you, George. I would love to have you help, or we can find some other things for you to do if you want to, but like this is not something that can be really done, I think. If you want, you can take the code and add logging to it if you want. But it is very messy though. It's not very maintainable. If you're interested, I can even just send it to you if you want to read it, but like, it's kind of stupid. But other than that, I wouldn't suggest wasting time on this. I think you can probably spend time doing something else better. But the thought, I really appreciate it. It is completely fine. Yeah, it's stupid as a... What does ChatGPT say? Nothing is crashing your bot. It's losing connection and resuming. What does losing connection mean? Okay, so maybe... Oh, interesting. So did I show this on screen just now? I forgot. But basically, we're having issues where you can see how it's reporting it resumed session, right? And it's resuming session every like sort of couple minutes like this. So 11:30 a.m., 11:43 a.m., 1:30 p.m., 3 p.m., 4 p.m., 8 p.m. And I think most likely what happens is that probably one of these timings aligned with the updates, and as a result, it caused the message to not be editable, and as a result, it had to write a new message. I think that's probably what happened. I think that's the most likely chance that this has happened. Like if we take a closer look, actually we can identify this issue, right? So we noticed that this thing was constantly repeated before. So it's repeated at 10:12 a.m. and then there's another message and another message and another message and another message and another message. And if you notice that there are no timestamps, right? The no timestamps means that these messages are sent back to back to back to back. And what that means is that a lot of people are likely leaving in sequence, and every time someone leaves, these things get updated. But because the server, the connection was down, every time someone leaves, instead of updating the old message, it ends up writing a new message. That's why there's a flood of messages here until 10:20 a.m. and then it still happened, and then it happened one last time. So I think actually we root caused it. It most likely is because of the disconnection here. This connection happened to coincide with the actual sort of updating, and as a result, it sent a message. Actually, if that's the case, how come it can send a message then? If you cannot edit a message, how can you send a message? What? So it does await channel.fetch message. At some point, probably timed out. If message is not none, try edit message equals to content, but this is message is none, right? Because it failed. So this doesn't work. We try new message, we await channel.send, and then we save state. And then, but there's also a failed to send message. So I don't know. It's very curious. Based on the footprint here, right? Based on the signature of failure here, it does seem to suggest that the failures seem to have happened in a very condensed amount of time. In a very short span of time, it happened multiple times. And it would then make sense if we were disconnected. So this is entirely possible. But what if this is 100% the case? I'm not 100% sure. So, but at least we made some progress here. And this is thanks to you, actually, George. Because if you didn't ask for this, I probably wouldn't have looked at this for like forever. So this is our final analysis at this time. You could try it, George, but there's no way to know if my bot is connected or disconnected. You'll just be gambling. Like, it's kind of just tossing shit at the wall. You could try it if you want to, but you know, keep in mind that like what happened is that if you look at the top time, right? So Deemer has like almost 600 hours. Over his 600 hours, this is the first time it has happened, right? Over the past 2 or 3 months that we've implemented the bot, this is the first time it has happened. So the truth of the matter is that if you try to replicate it, it's probably very hard. So the only way to do this correctly is to add logs, so that whenever it does happen again, we can testify, we can really truly check this hypothesis that way. But because it doesn't really necessarily affect anything in general, because what I can do is I'm just going to delete older messages if we already have a new one, right? Then it's fine, you know, it's whatever. It just spams us once in a while. It's kind of charming, I guess. But otherwise, pretty good. Oh, oops. How the hell do I leave this damn thing again? Control BD. Ah, yes. Select this. You can try it in another channel I create to see if it worked first. Oh, if you want to, yeah. You can set up a Discord bot that's monitoring on your computer, right? And then I don't know how you can introduce the failure. But you can introduce it, you can make it disconnect from web and then try to disconnect. Because you cannot disconnect your computer from web, so you might need 2 computers. You need one for the bot that you would disconnect, and then you need one for the actual one that you're doing it, the Discord, I guess. Anyways, I'll leave that to you, of course. Figuring it out is part of the fun. If you like figuring out stuff. I just want things to be done. No, better not click that. But oh shit. Yeah, no, George, don't worry about it. Even if you did figure it out, I wouldn't be able to fix it. Like, what am I supposed to do here, right? Like, what can we do if it doesn't work? Do we add a timer to delay it? But how do we know if we ever come back on, right? Like, and why is it that sending new messages work but not editing messages? I have no idea. Like, all of these things, unless you spend that much time on this, there's not much I can do anyways. So don't worry about it. But yeah, anyways, as usual. I guess I'll sign off here. I'll come back tomorrow for more talking and yapping and writing. I still have to work out the script's architecture stuff. I still have to get validation. Maybe I do have to pay for Plot after all, actually. Shit, that's not good. Oh, it is what it is, I suppose. Thank you, George, for chatting. Thank you, Igami, if you're still here. I see they're in voice chat, so you might have this stream muted, which is, of course, again, completely fine. That is what I expect to have happen. But if you're still here, anyways, thank you also for chatting. Today has mostly just been, well, it has just been this. Slightly carry on for the entire week, but see you guys tomorrow. Thanks for coming. Goodbye.